Good afternoon. My name is Demetrius Delancey, and I am an Operations Administrator in the Nature Conservancy's Caribbean Division. Thank you again for taking the time to attend this webinar on drones for conservation. This webinar will describe the methodology and lessons learned throughout the Drones for Conservation project. This project worked to enhance Antigua and Barbuda's ability to collect and manage spatial data through the use of unmanned aerial systems, or UAS, or drones. The project provided UAS equipment, software, and training, the development of a UAS policy and operations protocol, comparative analysis of mapping techniques, and a data management protocol, geodatabase schema, data standards, access, and use procedures. For the Department of Environment in Antigua and Barbuda, and also in developing a water quality improvement plan for the Woburn-Clacks Cades Bay Marine Protected Area in Grenada. Do note that we are recording this webinar so that we can make it available to interested persons who cannot attend. During the presentations, your microphones will be muted, but please do speak up or utilize the chat function if you cannot see the slides or are experiencing difficulties. First, I will provide some brief context, and then we'll turn it over to Dr. Kim Baldwin to discuss how drones can be used for conservation. This activity was completed under the Sustainable Financing and Management of Eastern Caribbean Marine Ecosystems Project. This is a 5-year, $8.75 million grant that the Nature Conservancy received from the Global Environment Facility through the World Bank. The grant started in November 2011 and will be ending December 31st, 2016. The grant was implemented in 5 countries in the Eastern Caribbean: Grenada, St. Lucia, St. Kitts and Nevis, St. Vincent and the Grenadines, and Antigua and Barbuda. The overall objective of the project is to contribute to enhancing the long-term sustainability of protected area networks in the participating countries. There are 3 main components of this project. The first component is to establish a system of long-term financing mechanisms to sustainably fund protected areas in the participating countries. The second component is to enhance 2 marine protected area demonstration sites in the Eastern Caribbean and to share lessons learned from those demonstrations. And the third component is to establish a regional monitoring system to help resource managers in the region measure progress toward protecting and restoring marine ecosystems and the lives and livelihoods they support. The Drones for Conservation project, led by Kim Baldwin, was completed under the second component of the project, and this webinar will be of interest to regional environmental practitioners looking to use UAS or drones for environmental management applications. We would like to thank Kim Baldwin for her wonderful work, and we hope that you find this presentation useful. Thank you again for taking the time to attend, and now I will hand it over to Kim.
Hi everyone, my name is Kimberly Baldwin, and I'm a postdoctoral research associate and GIS lecturer at the Center for Resource Management and Environmental Studies at the University of the West Indies Cave Hill campus in Barbados. I'm really excited to give this talk today, and I hope you guys find it useful. For those of you that don't know me, I've been at CERMES for over 15 years, and I did my master's and PhD there. I'm a marine biologist by trade, but I have a number of interests ranging from participatory research, participatory GIS and governance, to fisheries management, marine spatial planning, and marine habitat resource and species mapping. It's just in the past year I've been using drones. So the overall objective of the Drones for Conservation project, as Demetrius said, really sought to enhance the country of Antigua and Barbuda's ability to collect and manage environmental data through the use of drones. This project was implemented by the Nature Conservancy, and funding was provided by the Global Environment Facility and the World Bank Group under the Sustainable Financing and Management of the Eastern Caribbean Marine Ecosystems Project. This project was implemented for the Department of Environment and we worked collaboratively with the Surveys and Mapping Division, Fisheries Division, Civil Aviation Authority, Development Control Authority, Disaster Services, Coast Guard, Police, National Parks, and the NGO Environmental Awareness Group. I also included strong involvement with the media over the course of this 6-month project. As I mentioned, this project supports my postdoctoral research on marine mapping methods at TNC. Although the term remote sensing was officially coined in the year 1960, aerial photography using balloons dates as far back as 1858. Over the years, remote sensing technology and platforms have evolved from balloons and kites to planes and aircrafts and satellites in the 1960s and 70s. Since the early 2000s, drones were introduced by the CIA, and their use have now become mainstream. Drones are revolutionizing environmental science by enabling the collection of real-time, high-quality information. Unlike satellite imagery, which can be quite expensive, both the cost of drones and the level of expertise are rapidly decreasing, making remote sensing accessible to a wide range of environmental practitioners. Moreover, one of my favorites is that drones allows for the ability to collect your own data and determine when, where, and how this information is collected. Since drones fly much lower than satellites, they can collect extremely high-resolution images with an average pixel size on the scale of centimeters. Presently, the largest users of drones are for agriculture to monitor crops, and more recently, the construction industry for use in inspections. The largest global criticism today surrounds issues regarding military and safety, as well as policy and the regulatory environment. The largest limitation of drones is their battery life, and thus the scale or area of coverage you can map. Although there are a large number of applications that drones can be used for, today I will focus on their use as tools for conservation. These include enforcement, evidence gathering, and disaster assessments. Drones can be used to better plan deployments, improve access and safety at a fraction of traditional costs. Drones are increasingly being used for the protection of wildlife. For example, in Africa, they're used to protect elephants, rhinos, and tigers from poachers. Sea Shepherd has been using drones to combat illegal fishing for many years, and more recently, drones have been acquired by the countries of Palau and Jamaica for IUU fishing. Park wardens in Suriname are now using drones to combat illegal forest encroachment and track deforestation. Drones were also instrumental in planning a number of relief efforts in the recent Haiti and Nepal disasters. One real great benefit of drones is the allowance of real-time information that previously wasn't accessible, particularly in many small island developing states. Drones are widely used for conservation mapping and monitoring phenomena, such as habitat and flood mapping and monitoring changes over time, assessing vegetative health using an NDVI filter for precision agriculture to aid the effective application of water, pesticides, fertilizers, as well as quickly and accurately being able to assess environmental damages. Drones are useful for wildlife management, particularly in accessing impenetrable and remote areas. Drones are used for monitoring marine life, including whales, sea turtles, sharks, and seabirds, to map their location and population densities in an unobtrusive way. And drones are used by NOAA for oceanographic and atmospheric monitoring, such as for hurricane hunting. With the use of thermal infrared sensors, drones are extremely valuable for search and rescue missions, as well as for tracking animals under dense forest cover and allowing for surveys to occur during the night. UAS. A UAS, or unmanned aerial system, comprises the airframe, or unmanned aerial vehicle. The UAV will carry the payload, which generally comprises of a red, green, blue camera, a multispectral or thermal sensor, and is controlled by a ground control station using your mobile device or tablet. The UAS, together with flight planning and image processing software, can allow for the quick and easy generation of orthophotos and a variety of 3D spatial data. UAS are generally categorized into two main types. Small UAS, which are typically less than 55 pounds. This is the type that we used in this project and what I will focus on today. But there are also larger fixed-wing drones, which are still not that hard to use and allow for increased flight times and therefore the ability to survey larger areas. To allow for the efficient use of the UAS as well as the management of the resulting imagery and data, there were four main objectives of this Drones for Conservation project. In the development of UAS policy and protocol for the Department of Environment in Antigua and Barbuda. The second is I conducted a comparative analysis of satellite imagery and drone mapping methods at a demonstration site in the Marine Reserve. I had done the same area in 2011 for the government using satellite methods, or satellite imagery. The third objective was the development of a data management protocol for the National Environmental Information Management Advisory System, as well as we used a wide collaborative approach. We included a public sensitization campaign and also included the sharing of lessons learned both on national and regional scales. Project reports were produced for the first three objectives, which are now publicly available, and I'll give you a website or you can email me after the conference for more information if you're interested. But in today's webinar, I'm really going to focus on the main steps involved in setting up a UAS program, and we'll share key lessons learned and consideration for other practitioners looking to potentially use drones for their own conservation applications. To start, you really should take some time to clearly identify all of the possible applications you may have for drones. Here's a list that we developed in Antigua and Barbuda earlier this year. This step is absolutely critical to appropriately determine the type of drone, payloads, and mapping software you will require. Additionally, an honest assessment of your end user's technological skills, including the use of GIS, should be undertaken. Next, you should develop UAS policy and operational procedures to promote the safe, efficient, and lawful operation of the drone. This included a departmental policy, development of a UAS unit, which included the roles and responsibilities of the team members, flight planning, operational and safety procedures, as well as instructions on data handling, storage, and sharing, which you'll have a lot of if you start using drones. This project also included the development of training materials, and we conducted several two-day training sessions, which were essential for the safe operation of the drone. For example, your UAS policy would typically include a list of operational limitations, such as your maximum flying height, vehicle markings, flight inspections, etc. Here are just a few of the main limitations we developed in Antigua. Additionally, in most countries, there are designated no-fly or restricted areas. In this project, we worked closely with the Civil Aviation Authority to develop these for the country of Antigua and Barbuda based on international standards. Typically, restricted areas include airports, military facilities, critical infrastructure such as power plants, and highly populated areas. Although not designated in this case, we did leave an allowance to prohibit flying in sensitive areas such as wildlife reserves and national parks. Yet this was not set out in the Department of Environment's policy, as its primary use for drones is for using them for protected areas management. It should be noted that the Department of Environment can still operate drones in restricted areas once permission is granted from the CAA, or the Civil Aviation Authority. I would like to mention that in this project, we used a very wide collaborative approach with all relevant agencies of government from the outset of the project. I believe that this involvement, as with involving the media, was key to the widespread acceptance of the policy and the use of drones in the country today. Within your organization, you'll also want to clearly set out standard UAS flight actions and procedures. Here's an example of the flight checklist and the associated flight data sheets that were developed. This also includes a data handling protocol. As I mentioned, a large number, typically on the scale of hundreds to thousands, are produced from each mission flown, and the resulting surface reconstruction products, which also take up a lot of space, are created with each mission flown. So data management, especially as a GIS person, is extremely important. Within your operations manual, you also want to make sure that your flight procedures include protocols for requesting UAS missions, as well as guidelines for granting flight approval, in which the conduction of a flight feasibility and safety assessment is conducted prior to granting flight permission. This also can allow for special conditions to be set out for requested mission, such as flying within a restricted area or perhaps flying at night, as the police were interested in Antigua. Next, taking into account your intended application for the UAS and budget, you take time to carefully identify the type of drone and payload system or systems that you will require. In this case, the project provided the Department of Environment with 2 3DR solo drones, but there are other companies such as DJI, SenseFly, and Trimble, all with varying costs and applications, as well as skill sets that are required. Similarly, there are a number of payloads available, such as a true color or an NDVI camera, multispectral or thermal sensor, and depending on your needs. Here I have a list of the general UAS equipment we purchased in this project. Also note that we have 14 batteries for the 2 drones. This is because each battery results in approximately 15 to 20 minutes of flight time, in which we're able to map, on average, 5 to 10 hectares per battery. Total flying time also varies depending on the wind speed. And the mapping extent is relative to how high you're flying, whereby the higher you fly, the more area is captured per flight, yet your resolution is sacrificed. So therefore, you really must experiment with flying a bit to find that right balance for your needs. So after you've got your drone and you have your protocol, you collect your data. So data acquisition is typically done using application or a flight planning app. There are a number of free open source applications available. These are typically platform specific or based on the type of drone you're using. For example, we used a 3DR, so we were using the Tower app. DJI has its own app in which you set out but they all work the same. So you set out your survey area of interest, as well as other flight planning parameters, such as the flying height and the amount of image overlap. Next, all images acquired must be geotagged or given spatial reference information. Again, depending on the type of drone you're using, geotag is either done automatically by the drone or manually after flight, whereby a program is used to connect the timestamps from the drone's images to the GPS location collected by the drone's telemetry log. Once your images are geotagged, post-processing and service reconstruction is a relatively automated process. Image processing software such as Pix4D uses photogrammetry techniques, which are based on measurements derived from overlapping photographs, to stitch together the images and create an orthophoto mosaic and a variety of 3D surface models. There are a number of analysis tools that are also built into these programs, such as volumetrics and NDVI calculations, which are useful to assess vegetative health. And these are actually really easy to use. So in this case, we use the program Pix4D, which is probably one of the more advanced applications. But there are a number of other programs, such as Drone Deploy, Drone to Map, Drone Mapper, each with varying costs and output products available. Overall, this technology is extremely inexpensive as compared to hiring professionals to post-process your data. Post-processing software ranges from $10,000 to $100 a month, depending on your needs. Processing time to process each flight that's flown is typically a few hours, but ultimately this depends on the number of outputs chosen and your computer's processing power. For example, I'd recommend a minimum of 8 gigabytes of RAM, but a processor with 32 gigabytes will run substantially faster. Some software applications, such as Drone Deploy, use a cloud-based processing in which the final results are sent to you, thereby reducing your need to have a fast processor. Pix4D also will provide you with a detailed quality report shown here, and it allows you to get into the back end of the program to improve your data output. Surface outputs can all be exported as a GIS shapefile or a geotiff, as well as Google Earth KMZ and AutoCAD file formats. Here's an example of the input flight parameters and the results provided in a quality report for a mangrove survey conducted at the Cades Bay Marine Reserve on the southwest coast of Antigua. As I mentioned before, we're typically able to map between 5 to 10 hectares, or approximately 20 acres per battery. But this was an extremely windy day, and I think we had some technical difficulties at the start, so we didn't really start with a full battery in this case. One lesson I think we definitely learned is that there always seems to be some hiccups with flights. It should be noted that your payload weight can also significantly reduce your flying time. Luckily, multiple flights can easily be stitched together with the post-processing software to map larger areas. So as you can see here, our overall accuracy in this case was less than 4 centimeters, with a ground sampling distance, a GSD, or a pixel resolution of less than 1.32 centimeters. The relative accuracy is 1 to 3 times the ground sampling distance of the original images, and the absolute accuracy is 1 to 2 times the ground sampling distance horizontally for the XY coordinates, and 1 to 3 times the ground sampling distance vertically, or the Z coordinate. If you want to further improve your accuracy, ground control points can be used. In this case, and in all of the cases I've flown drones, we have not used the ground control points. But if you're a professional surveyor, you definitely can use survey instrument, in which the accuracy will depend on the accuracy of your survey instrument, the number of ground control points used, and their distribution in the survey area. So overall, we found that UAS technology resulted in extremely high resolution imagery with features approximately 20 centimeters inside to be easily discernible. The NDVI sensor allowed for the calculation of a vegetative health index, which is useful for quantifying the photosynthetic capacity of the plant canopy. The production of a digital surface model provides for the visualization of a watershed, including the ability to quantify the impacts of coastal inundation, erosion, and flooding effects. The conduction of volumetric measurements within the Pix4D software is possible, but I think it should be noted that at this point, the software is only calculating a digital surface model, which is the canopy top. Therefore, if you wanted to calculate the canopy height and the biomass of the mangrove, it would only be possible if you had a pre-existing ground surface model or LiDAR data. Lastly, mapping of marine environment is still limited a bit by water clarity and depth, and requires some special consideration in terms of sea surface state and sun glint. Basically, you want to map shallow waters that are relatively clear and calm. We found this to be typically earlier in the mornings with the sun at an oblique angle behind the camera. And you can see the difference in these two marine pictures of good and bad sea states. Result. First of all, the benefits of using drones are that they are really, really fun. The media absolutely loved this project. I got more coverage than I think I've ever gotten doing any other environmental work. Drones are really an easy-to-use conservation tool that allows for the cost-effective acquisition of real-time, high-resolution data, both spatially and temporally. Drones can allow access to remote terrain and are also insensitive to cloud cover, an issue which commonly plagues satellite imagery in many island states. Moreover, the use of drones can be very empowering for local communities to not only participate in research and enforcement activities, but can allow them the power to create their own maps. Despite all these benefits, there still are some limitations of using drones that I should mention, namely the mapping extent. As I mentioned previously, if you are mapping a large area, such as an entire island, satellite imagery would be much easier and more cost-effective. Payload weight restrictions still limit the type of sensors that can be used with drones, although recently, LiDAR sensors are being engineered for small, fixed-winged UAS. Although drones are relatively cheap and easy to use, a significant initial investment in both time and money are required, especially the time to practice. There's a high potential for the loss of the drone from a number of factors, such as crashing, rain, or flying over the marine environment, which is why UAS training, practice, and a thorough operations protocol are extremely important. I would really suggest perhaps starting with a cheaper drone when you first start out and work your way up. Lastly, most countries are presently scrambling to put UAS policies in place. And unfortunately, in many areas, particularly the United States, these laws can be quite restrictive for research. It is therefore critical to thoroughly research your regulatory environment in advance of purchasing a drone. I believe that UAS can play a critical role in mitigating the lack of current and accurate data to support informed decision-making and management. We found that drones are relatively inexpensive and easy to use, particularly if you have a solid foundation in GIS and technological skills. This project spanned a 6-month period in which a good deal of time was allocated to practicing both the flights and the use of the software. My team in Antigua was flying approximately twice a week, in order to master their skills for the first few months. I would also recommend that you carefully identify your intended applications in order to find a balance between your needs, budget, and capacity. Not all drones and software are built alike. There's different drones and software that are better suited for different purposes. As I mentioned, careful attention to weather is absolutely critical, especially in an unpredictable environment like the Caribbean. Rain or an accident in the ocean is fatal for your drone. We learned the hard way, I almost lost a drone once, that the wind speed of less than 12 miles an hour is ideal. Also, besides losing the drone in high winds, the pictures come out blurry if it's too windy. Dense clouds are actually your friends, as bright light can result in overexposure, and you can see this here in the picture in the middle. Early mornings, shallow water, and a clear, calm sea surface is absolutely essential for mapping reefs or for sighting marine mammals. As I keep mentioning, drone regulations present the largest barrier today. Most countries have special regulations and protocols for using drones for research and may require special flight permissions, special licenses, as well as public liability insurance. Last but not least, training, good UAS, and data handling practices are essential for safe and efficient operations. I really hope this webinar was useful, and happy flying, everyone. I'd really like to extend special thanks to Jason Williams, the Department of Environment, the members of the UAS unit in Antigua and Barbuda, as well as the government of Antigua and Barbuda, and the Technical Advisory Committee who worked closely with me throughout this entire project. I'd also like to thank Dr. Steve Schill of the Nature Conservancy and Dr. George Raber for training myself and conducting a 2-day training exercise for us at the start of this project. I'd like to thank Renata Goodrich and Dale Benskin of Cerames UWI for flying drones with me in Barbados, the Nature Conservancy, as well as the Global Environment Facility and World Bank Group for funding this project, as well as some additional support that was given by the Eastern Caribbean Marine Management Areas Network under the German government's International Climate Initiative. Thanks for joining this webinar. I have here my email if anybody wants to contact me, as well as the website for the Department of Environment in which the project reports should be available. They're actually undergoing construction of that website right now. So Jason said that if documents are not up on the website, they will be soon. Otherwise, you can email me and I can share those. Thanks.
Yes. Does anybody have any questions?
I'll jump in if that's possible. My name's Catherine Wensink. I'm from the UK Overseas Territories Conservation Forum. I know that this presentation was all about unmanned aerial drones. I just wondered if you had any points to make about the underwater submersives that are starting to be used for 3D mapping in the marine environment.
I hope you can hear me. I have not used the underwater 3D submersible drones. Steve Show, who trained me, he has drones that you can set on the surface of the water that will take pictures. But I'm sorry, I can't comment on those.
Okay, thanks.
Hi, Kim. We have a question. It says, any suggested resources for drones in marine enforcement cases?
I've got plenty. I'm actually publishing a paper right now on the whole subject. But if that person wants to email me, I can send them links to many of those that I have.
And the other question was there a particular reason for choosing the Solo over the DJI Phantom series?
Steve Schill picked out the Solo. I personally would recommend starting with the DJI. The team in Antigua were extremely tech savvy, so I think that's why we were very successful. I would say if you just were starting out, there's a lot, because the Solo, everything's built in the DJI. The camera, the geotagging, as I mentioned, in the DJI happens automatically. So when you're done, the pictures are just uploaded to the cloud, and it's a pretty seamless process. The Solo, on the other hand, it's got an area that you can attach a lot more payload. So the benefit there is that you can add a lot of different sensors and you can customize the Solo. But it is definitely requires a little more technological skills. You've got to manually use another program to geotag after. So there is, like, as I mentioned, there's different drones there, and then there's the SenseFly. Now that is a real advanced drone that can do an amazing amount of work. But again, more skills are needed. So as I mentioned, it's really important to just, go piece by piece. The problem with the DJI is that you're only able to add the red, green, blue camera. That's what comes standard in the DJI. But I would start with probably a DJI. They're definitely a lower price point, very easy to use. And then as you get better, you move your way up. And as I mentioned, if I were budgeting for a project, I would probably get a couple drones, knowing that if you got a good year out of flying it without it crashing, you probably did pretty good.
Another question. How did you assess horizontal absolute accuracy of your finished maps? And did you assess vertical accuracy of your digital surface models? And what was the average?
Okay, that really depends on the images. I'm giving you those numbers based on the Pix4D software. So that was based using Pix4D, and that comes straight from their manual, those numbers. So again, I can't tell you the accuracy because it really depends on the images that were taken, whether or not you use ground control points. As I mentioned, the horizontal accuracy is 1 to 3 times, and the vertical accuracy is 1 to 2 times the ground sampling distance of the images. And if you needed the accuracy to be extremely high, you would want to make sure that you're using ground control points and a survey grade GPS. And then the accuracy would be based on whatever the accuracy is of that survey GPS.
Another question. Have you had any successes counting, identifying, or observing marine mammals in your study region?
I personally have not used them for counting marine mammals. The Barbados Sea Turtle Project has acquired a drone for using them for turtle nesting, but that is not a project I've undertaken. I've just read extensively about people using them for whales, dolphins, sharks in shallow mangrove areas, like baby sharks, as well as bird nesting. But like I said, I have not gone out and done those projects myself yet.
Another question. What was the criteria for choosing the 200 feet flying height?
Good question. Really, the flying height depends on the purpose for your mapping. I prefer to fly actually at about 300 feet because even at 300 feet, you're getting a wider area. So again, as I mentioned, it's a balance between what resolution you want and how wide of an area the drone. So the higher your drone's flying, the wider a swath you're mapping. And then you need to have a certain amount of overlap, which is typically 75% overlap of all your images you would want, especially if you're doing 3D modeling. So we chose 200 at that point. That was just showing you one flight of hundreds of flights that were done. But typically I fly at about 300 feet in most cases. And that was the height in Antigua we chose as the max flying height because helicopters are flying in Antigua for tourism. They're flying at 500 feet. And so Civil Aviation Authority wanted to max the drones out at 300 feet. Are there any other questions?
We have a question. Where did you get your funding from?
I stated at the beginning of the project, the Global Environment Facility, as well funded by the World Bank, is who funded this project, and it was implemented by the Nature Conservancy.
Another question. What are the plans for the future?
For me, for government of Antigua, yes, talking about me, I would love to go out and keep mapping with drones. I'm interested in training more people how to use the drones. Like I said, it's really easy to use. We're training people in Barbados right now, the university, and really this whole project and program, I mean, it took us 6 months. Because I think we're just developing all the training materials, but all that's done now. So a project like this could be coming and done in a country in, I'd say, a month's time. Training, maybe about a week of hands-on training. And then, you need a few months of practice time, I'd say, for sure, to really get good and work out things. And I think that people that want to implement a drone program should really make sure that they, if you're a director and you want to implement drones, allow time for your staff to go out there every week and practice because the learning curve, you learn really quickly. And I was shocked at how great and easy to use this technology is, but you do need to put in some time. You need to learn to fly the drones, feel comfortable, use the software. But overall, this is just amazingly easy to use compared to conventional satellite imagery and remote sensing.
Another question. Are you planning on trying any multi-spectral cameras? And have you done any work with fixed wings?
I am going to be working with a team in Canada that has fixed wings. I have not myself. And yeah, they've got multispectral cameras. So yes, that's in the future for me.
And persons are asking, Is there any way, and I guess you could probably use your email to contact you about additional materials and experiences concerning drones?
Yeah, as I mentioned, if it's not on the Department of Environment's website yet, the data UAS policy and protocol, which shows all those flight checklists and data sheets we created, that's one publication that I produced as this project. The second publication was a comparative analysis of mapping methods using satellite imagery versus drones in the Cades Bay Marine Reserve, which I mapped using satellite imagery in 2011 for the government of Antigua. The third manual is the EIMAS, which is their environmental management system of the government, their national environmental management system. We developed a data management protocol. As I said, you get a lot of data. So having storage facilities and understanding on your server or hard drive where you're going to be backing up all this data is critical. So there's also a paper on that as well. There's training materials which are not publicly available, but I have those created. And as I mentioned, I'm also going to be I'm looking to publish in a journal, a paper about this coming out in the early part of next year. And you can contact me. Maybe I can try to get that made available on the CERME's website as well.
We have a question. Have you been in contact with others developing drone projects throughout the Caribbean, or are you aware of any efforts to unite protocol or research strategies given similarities in needs and habitats?
That's a great question. I've not heard of any regional effort to try to put things together, but I would strongly recommend that this is a way forward in the future and really trying. I worked with, as part of this project, as I mentioned, the Civil Aviation Authority in Antigua and Barbuda. I live in Barbados, and so they're developing their drones laws now. We also worked with the Eastern Caribbean Civil Aviation Authority, and they were involved in this project as well as the policies that were developed for the country. So I think it's something that we really need to come together and try to have uniform laws, as well as break these barriers that drones are a threat. I think countries are kind of scared, people in general are scared, which I can't emphasize but enough, using the media and getting people understanding the benefits of drones and that they're not this invasive privacy thing or threat if they're done right and there's protocols followed and people are trained properly. And I think from the outset, involving all the agencies in Antigua, they're very drone friendly now in Antigua. Whereas I can't really say the same for Barbados. There's a moratorium, a ban on drones. There's only about 40 of us licensed in the country of Barbados, and they've restricted the importation of drones. And there's several countries that have actually put bans on drones. So that is something that we need to move forward, and really education to get people to understand how drones can be used in a positive way is critical.
Question: have you had the opportunity to use FLIR cameras?
I haven't, but if you saw, I had a picture there with a little deer that was light up. That's the infrared camera sensor that you can use. I haven't personally used them. I've seen some great stuff on YouTube with researchers. I think it was in Suriname, using them in the forest to track bats at night. I've also seen them used for search and rescue efforts. And those cameras are amazing. But no, I haven't. It's just a small sensor that you can attach to the bottom of a drone, though. I think nobody's really asked, but how much should you really budget for using a drone? I would say probably including like the training and developing your protocols, but just for the hardware, software, you could probably get away, with under $5,000 US to have. I mean, the DJI drones now have come down. I just saw for Christmas specials, less than $500 for a drone that can do mapping. And as I mentioned, the drone software, there is some open source software, but you probably need a little more technological skills. But, even a company like Drone Deploy, you can rent the software by the month. It's $100 a month. And then you need to buy all the accessories and bells and whistles. So I'd definitely add in another $500 to $1,000. So if you had a budget for about $5,000 US, you could pretty well be set up. Remember, you have to buy tablets for your controllers. There's a lot of little things. And again, I think in one of my reports, we've got like a list of all the equipment that we did purchase for this project. This project, we spent significantly more money. We bought the Pix4D software, which was $10,000, and we had purchased 2 drones and a lot of bells and whistles in terms of accessories. So I think that they spent closer to $15,000 to $20,000 on equipment for this project.
Another question, can you recommend an open source processing software?
I know I haven't really explored too much. I forget the name of, there is one that's out there that's open source, but also if you were to just wanted to play around, Pix4D and Drone Deploy, their flight planning apps do allow you to do processing for free. It's just the functionality is limited. You can get a stitched together ortho mosaic for free from either one of those applications. The problem is they'll give you a screenshot which will show you the 3D model, it will show you your elevation model and all the other things. You just can't access them without paying for the software. So if you had a drone, you could go out today, you could download the apps, the flight planning apps that are relevant. So the Pix4D one's called Pix4D Capture. The Drone Deploy one, I think it's just called Drone Deploy. You could go out, you could fly missions, and you could upload them to these websites, which they'll process it and spit you out just a stitched together image. So if all you care about is an image, with 100 pictures stitched together, you could go out today for free and fly. But if you wanted to export it as a GIS shapefile or a KMZ or, a GeoTIFF, you're going to have to pay for the software. But as I mentioned, Drone Deploy, you can pay by the month, $100, I believe it is a month. You get a free 30-day trial as well.
Are there any other questions? Okay, so thank you. Thank you to all our guests, and thank you to Kim for the presentation. Please note that this presentation has been recorded, so you will be able to access the recording at the later date. And also Kim has posted up on the slide information and also her email address if you had any additional questions for her. So thank you everyone for joining us today, and have a great day.
Yeah, thanks again, everybody.